So my name is April Edwards. I'm a senior cloud developer advocate and DevOps practice lead at Microsoft. I sit in the UK. I do so much work in the Netherlands because there's an amazing community of technical people here, and you're close, right? You're a quite quick little flight or a swim away. So this is my buddy, Sir Titan. He's been requested to be on screen today. He is sitting in England. Sir Titan immigrated to the UK about 8 weeks ago from the US. He's my developing buddy. We write code together. So before we get started, I want to talk about something that's really important to my heart, right? I'm a female in tech. There's a lot of females in the crowd. As part of Microsoft Build, we're raising money for girls who code. And for those of you that have followed DevOps topics, you may remember our very late friend, Abel Wang. We wanted to raise money for girls who code, so we're asking everyone to take some time and donate. I have to close off the donations this evening, and I'm going to send it off to Microsoft to match pound for pound, dollar for dollar, euro for euro. So everything we raise here in this fundraiser will get matched 100% by Microsoft. So I'm going to encourage you to donate today because I do have to close it off this evening. So what is DevOps? I want you to go ahead and shout it out. How would you define DevOps? Mindset. Culture. A hassle, yes. But all of us have a very different definition of DevOps. Why? Because we have all different life experiences, technical experiences, backgrounds, etc. So we're going to level set here and talk about how we define DevOps at Microsoft. We define DevOps as a union of people, process, and technologies to enable continuous delivery of value to our end users. And I want to talk about this word value, because it doesn't matter if you're a developer or IT pro or security person or PM, whatever it is you do, are you delivering value? So why do DevOps matter? Because your competition's already doing it. In the UK, we have a massive issue with the taxi companies and Uber. Why? Because Uber's outperforming the market, and they're just one example. But we know these high-performing DevOps organizations achieve more because we have metrics. They have over 900 times more frequent deployments, and they have faster commit to deploy, and they also can recover from incidences faster because we're all going to have an outage at some point in time. So sources of vulnerabilities. We introduce the most vulnerabilities into our production environments in that development process, but we find out in production, and that costs us more to remediate in production than it does into development. So we need to start in development. And I'm going to talk about this thing we call shifting left, doing things early and often. If we think about a lot of the cloud breaches that we've seen out in the world today, 95% of them are down to human error. How many of you have ever made a mistake deploying something? I should see every hand raised. We all make mistakes. We're human. So we need to find a way to automate things and to enable us to do more earlier on in the process. When we look at customers that have had cloud breaches, Uber's actually had one. So is Capital One, Equifax. These were all down to human error. Uber's hack was because someone put a password in their GitHub repository. Equifax had their web portal hacked, and they saved all their passwords in plain text. Now, how many of you have been on a project, you're rushing, and you save that password in plain text, and you're like, yeah, I'll deal with that later. We've all done it, and that's a problem. We need to stop doing it, because when we do get a breach, it's going to cost us millions of dollars, pounds, and euros to recover that. So I want to talk about shifting left. We want to do things early and often, and we want to fail fast. So let's talk about secure software development. We want to secure our development environment. Security starts when you clone your code to your laptop, to your device. So everything I do today, security starts from here, from me. Then we need to embed security into our developer workflow. Whether you're a developer, IT pro, into your daily workflows, we need to embed that into our practices. And I can tell you, when I moved from operations into development, I didn't care about security. It was hard. I'm like, there's a specialist for that. I had to learn to care about security in my code, into my processes. When I'm writing infrastructure as code, I don't want to put a connection string or a password. I have to think about those things. And we need to bridge the divide between our development teams and our operational teams. How many of you work in ops? Okay, and how many of you work in development? So there's a good mix in the crowd. These teams are very often siloed, and we're incentivized so differently. as an IT pro, I'm incentivized to keep those lights on in my infrastructure 24/7 by 365. And if something goes down, I'm out of job. As a developer, I'm there to push new features. And those two things absolutely clash every single time. So we need to knock down those silos, stop the blame game, and start doing things early and often, because it's all of our responsibilities. So the good news is, Microsoft has an amazing tool set that we can integrate. Not only do we address what the developers and the IT pros want to do, but also what the security teams want us to do. We need everyone involved from day one. So we have tools like Visual Studio Code. We're going to talk about GitHub CodeSpaces. We're going to then use a GitHub repository and GitHub Actions. We're going to live deploy something into Azure, and I hope it works. But as we do this, I'm going to embed security in what I'm doing. I'm going to secure my developer environment and secure that workflow from end to end. So this is going to be a full end-to-end DevOps deployment. So where does security fit into the DevOps lifecycle? Every single point. Before we commit our code, where are we writing our code? I've worked with customers that use Notepad++. And I was working with a customer, and this person on the team was looking at his infrastructure as code in Terraform and went, I can't find this, I need your help. I've spent 4 hours on it. The customer did not find VS Code as an enterprise-level product. So the customer itself used Notepad++, we're using VS Code. I pulled down that person's branch and found their mistake within 10 seconds. He goes, how did you do that? I have a linting tool. It highlights when I do something wrong. It helps me write better code. So we overcame that hurdle, and we convinced the customer to use a better IDE because we want to enable how they're working before we commit our code. And in that customer project, we did peer reviews. I couldn't just submit my code to my main branch and make changes. Someone else had to review my code. And 2 people had to review my code. One from someone on my team that wasn't me. I could not self-review my code. And then someone from the customer, so they're aware of the changes, because we worked together to build and deploy their code into their environment. So having these secure standards are really, really critical. When we commit our code, whether it's infrastructure as code, C#, Golang, doesn't matter the language, we need to look at static code analysis, right? And when we submit our code, are we running security unit tests? These are all important things. When we go to deploy our code, are we using security scanning? Today, we're going to talk about Microsoft Defender, because I'm going to build an image, we're going to package it, we're going to send it to Azure. But before I can deploy it to my next phase in my environment, I have to have a secure image of my product. And the next phase of DevOps is having that operational monitoring phase, and this is absolutely critical. And I was working with a customer recently, and they're like, oh, we do DevOps, we do all the DevOps. But how do we figure out this thing? And I'm like, hook in monitoring. And that clicked. A big customer doing all the DevOps forgot to do monitoring, because we need that intelligence feedback to make it better for the next time we kick off our cycle. So we're going to talk about GitHub CodeSpaces. Why are GitHub CodeSpaces important? Because we want a fast, standardized, and secure way to deliver our code. So whenever I work with customers, or I've participated in a Microsoft Open Hack, which is a free 3-day event to learn the tech, it takes us half a day to get started. How many of you get started on a new project and it takes weeks to get set up? It takes such a long time. I just want to write my code. I'm being prohibited to do my job as a developer, and I'm waiting around twiddling my thumbs. We don't want that. So we can spin up a GitHub CodeSpace so that everyone's environment is the same and it's secure, and we can standardize it. I can code from anywhere in the world. Better yet, who's used the phrase, it worked on my machine? Yeah. I don't like hearing that phrase. Half my team work on Macs. I work on a Windows device. It's personal preference. At Microsoft, we get to choose our device. So saying it worked on my machine doesn't fly, because we're always developing either in a dev container and or a GitHub CodeSpace. We need to secure our pipelines and infrastructure. This is absolutely critical. This is the whole build tampering that we need to talk about. Who has access to your pipelines? Who has access to your repository? Don't just give administrator access because it's easy, because that person can tamper with your build. They can tamper with your pipelines. You give unauthorized access. We talk a lot about this in Azure, role-based access control. It is coming to GitHub to get more granular control into your pipelines. And we're going to talk about GitHub Actions. GitHub Actions are amazing. They automate everything. They literally automate everything. We talk about shifting left, right, and our compliance left, doing things in these workflows. We want to be able to operate seamlessly. But what's cool about GitHub Actions is Yeah, they accelerate how we do things, and it's CI/CD, but it's so much more than CI/CD. We can literally automate anything with a GitHub action. So not just continuous integration, continuous delivery, which we're going to do today, but they're easy to use. I can go into GitHub portal, into the marketplace, and I can pick up actions for Azure and just plug and chug them into a pipeline in YAML. And before we all complain about YAML, it's a love-hate, right? It's yet another markup language. I love YAML. I've grown to love it. It took me some time, but I've loved it. But it's so easy to create actions and to automate something. You can automate something in your repository. Maybe something as simple as someone joins a project and it automatically sends them a message or sets up their privileges. You can literally automate anything from GitHub Actions. So there's so much more than just CI/CD. So instead of talking about DevOps, we're going to go into a demo. Who is ready for a demo? I know, we just got through lunch. I'm sorry. So I've built a website. This is really simple. Really, really simple website. Why? Because I don't have the coding skills to build a really pretty website. But we've built a really nice website. But we want to make changes, okay? We are sitting here at Azure Lowlands. I'm going to go into my GitHub repository where my code is sitting. I've opened up a GitHub issue. I've opened up an issue to say, I want to change our website for Azure Lowlands. So you all in the crowd are going to help me deliver this website, okay? So anytime I'm in a GitHub repository, I want to make changes to my code. There's a couple things I can do. The first thing I can do is I can hit a period or full stop, depending what country you're in, and it opens up a web editor. This is a great way to work from my browser, but it's not secure, okay? It's not the same thing as a GitHub CodeSpace. It allows me to access my repository and my code. I like to use this for maybe an edit on a README or something really simple, not to actually edit my code, but we absolutely could. Now, the other thing is my extensions don't work in this editor. So I have tons of extensions here for linting, code review, etc. I can't see any of them. I also can't run and debug my code within the editor. So it's not really a full-fat product, but it's a kind of a quick and dirty way to change your code. So I want to spin up a GitHub CodeSpace. So we see the issue, we saw the issue. I want to go ahead and spin up a GitHub CodeSpace, and we're going to make changes to our code on the fly. So traditionally, when I get started on a GitHub project or any project, I need to clone my code. So remember, that security starts when we clone our code. And so often, as developers and IT pros, our machines are locked down. And how many of you have been given a really old machine with like 4 gigs of RAM? That machine's not running tests. It's not doing anything, right? So I need to be able to allocate to my developers a code space so they can write their code. So instead of cloning my code and getting everything set up and installed locally, I want to set up a GitHub CodeSpace. We're going to configure and create a GitHub CodeSpace together. So when I create a GitHub CodeSpace, if I have multiple branches in play, I can create it directly from my branch. I'm going to go ahead and spin it up from my main branch. The other thing is we can look at what region to deploy our GitHub CodeSpace from. We're sitting here in Europe, so I'm going to go ahead and use West Europe, which is also the closest data center for me, sitting in the UK. And then I can choose my machine type. Now, in the organization I'm working from, in my GitHub repo, I can change that machine type. You can also limit to what your developers can do, i.e., don't give them access to a 32 gig machine. But by default in this repository, I get 4 cores, 8 gigs of RAM, and 32 gigs of storage. If I exceed that limit, I can scale that up. So I'm paying for the compute that I use, and this is all sitting on Azure, and this is building a container. Now, I don't have a dev container in my repository. I'm a bad developer. I'll slap myself for that later. So I could absolutely spin up my dev container with all the extensions that I need, ready to go, and all the testing tools. So we can see it has loaded my code in my repository. Let me go ahead and make it a little bit bigger for you. And on the left-hand side, it's loading all of my extensions. Everything that I'm used to working with on-site, on my local to my machine in VS Code, I can use in that GitHub CodeSpace. And if I load a specific dev container instead of the default one, I can specify what my developers can use. So I can live share. I could send a live request to anyone out there today to work across our code. So if you haven't used live share before, how many of you tried to share code over Microsoft Teams? Yeah. I was doing that a couple weeks ago with a colleague, and he calls me and he's like, I really need your help with something. And we're working in teams, and I'm like, this is like watching paint dry. Live share is coming to Microsoft Teams. So not only can I use it in CodeSpaces, locally on my VS Code or Visual Studio, it's coming to Teams. I can go ahead, share my developer environment to someone else, and we can make changes together. So I'm sitting here in the Netherlands, I could call a colleague in the US, share out my code, and we could collaborate on this together. All my extensions are loading. I can also run and debug from within the code space. I can run my tests. I don't need to do it on my machine. So what we're going to do is we can see down here we're running in a code space. I'm not going to work off my main branch because I'm a good developer. Sometimes. I'm going to go ahead and create a branch called Azure Lowlands. So this is going to be our working branch. Good developer practice, don't work from the main branch. I'm going to go ahead and make a very small change to our website. What should we put it as? Anyone? Anyone? Bueller? Quiet. Come on, help me. What am I going to rename my website? It says welcome. All right. Welcome to Azure Lowlands. 2022. Good shout. Thank you. So it's automatically saved my changes. I'm going to go ahead and push those changes into my GitHub repository. And it's going to publish this branch. And I can go ahead and create a pull request from in this branch, or I can go back to my repository where I've been working, and it sees that I've pushed this code up, and it says, do you want to open a pull request? Now I can do that within my code space, I can do it within the GUI here, doesn't really matter. We're going to go ahead and create a new pull request for our code. So we're going to merge our Azure Lowlands branch into our main branch. We want to go ahead and put in some notes. I can add reviewers to this. So I can add some friends, I can add some colleagues, who's ever in my team. I can assign myself to this task. I can add milestones. I can assign this to a specific project. For now, we're just going to go ahead and create our pull request. As we initiate the pull request, we can see that things are going to start running in a moment. Before I can do anything with this pull request, I have to run through a lot of checks. Now, the other thing is we're going to deploy this to Azure. Do we want to deploy this directly to production? No is the correct answer. So this is running two different GitHub actions. One is a CodeQL analyzer, and the other one is our multi-environment workflow. So I've set up multiple environments within GitHub, so I'm not deploying to production. Again, I'm being a really good developer. So while that's deploying, let's look at what I've set up to configure everything. So we're going to go to the actions themselves, and we can see I have two actions running. We'll go to the CodeQL change first. So CodeQL, what does it do? It treats our code as data. And it scans our code, and when I open up this action, it has analyzed my code, and it sees that I'm running JavaScript in my code. If I'm running C#, Golang, Ruby, etc., it will pick that up automatically and put this in as a tool. Now, I can take CodeQL, and I can change this workflow. This is the default it spits out for me. And we can see here it's pulled up my JavaScript language. I didn't have to add this. So if I have other languages in my repo, it will pick that up, pull that in, and it's going to run it against my code. And it's going to tell me when I build that type of code, are there any issues with my packages? Is there any issue in my code at all that I need to be aware of? We also have our multi-environment workflow. So it's doing a lot of things here. Let me go ahead and make this a little bit bigger for you. So the first thing we're doing is we're building a Docker image. Why am I building a Docker image? Because I want my application to be portable. I want to deploy it to multiple clouds. The reality is most of our customers are multi-cloud, and most of our organizations have multi-cloud strategies. We also may be working on-prem. So I've containerized this app, I've packaged it, I'm deploying it up to my Azure Container Registry, and we can see a scan down here. It's running Microsoft Defender against my image. So what have I done? I've pulled out a secure development environment. I've changed some code. Before my code goes to production, I package it, ready to send it out. I'm now testing my code, and now I'm scanning it. So I'm going to drill down into our little workflow file and see what it actually does. So this workflow file here is triggered on any type of pull request. It means that I can't just submit to my main branch. Why? Because that's a bad idea. Even if it's just a small, tiny change, that comes back to bite us, doesn't it? Every single time. So when we're deploying our code, I promised you that we're building and pushing our Docker image. I want to make this portable. The other thing I've done with my Docker image is I've tagged it with the GitHub SHA code. You could use a pull request number, whatever tagging methodology works for your organization, but I've used the GitHub SHA code to track this end to end. I'm also saying this to application insights. So I'm hooking in my monitoring from day one when this application goes out. And it's going to deploy this container to Azure. And it's going to go to a dev environment. So this dev environment, we'll be able to see our changes and approve it through each stage. So I told you I'm using environments. So in my code, I have a dev environment. I have a test environment, a production environment, and a staging environment. I'm going to build the dev first. It goes to test, staging, and production. Each of these environments have secrets tied to them so that they don't cross-reference each other. Whether I'm using Azure Key Vault, et cetera, or GitHub secrets, it doesn't matter. So I can go down here. I've set these up. And I've put in different environment secrets for each environment so they don't overlap. Because each of these environments are different in terms of their separate entities, their separate Azure resources, but they are like for like. This script deploys the exact same environment out. How many of you deployed stuff to your test environment and it's a dusty box in the corner? Yeah, we've all been there. We get the dusty thing in the corner to test with, but that's not like our production environment. So the Azure resources are identical and exactly the same. So we can see our code QL ran successfully. It's completed. I can click on it and I can drill down into what's happened. I can export the script. It's built our code, it's performed an analysis, and it's happy, so it continues. So this change to our website's still running. So it's built and pushed our Docker image. It's currently deploying to that test environment. So while it's deploying to our test environment, I want to go talk about some of the security features that are running as we're running this deployment, and then we'll come back and check on our delivery, because we might fail. We might have, a bad image. We might have bad code somewhere. So we're going to talk about GitHub Enterprise. How many of you currently use GitHub Enterprise today? A few people out there. What they've done with GitHub Enterprise is they've enabled greater security features for the enterprise to deliver whether you're on-prem or in literally any other cloud. So they want you to be able to literally automate everything in your software delivery, whether you're using packages, your continuous integration, and shift that security left. Because remember, as a developer, I hate thinking about security. It just wasn't something that was like first on my plate. So they built in things like code scanning and secret scanning. And then collaboration. So while this is all going on in the background, I can hook GitHub into teams. Because one of the biggest part of DevOps and deploying together as a team is that communication. And we've all been there on a project where we sit there, we're working on something or something's broken, and someone's tapping on your shoulder going, is it up yet? Right? So having that communication is really, really important. So how do we develop secure code? So when we talk about the different attacks like Uber, they put that password in a plain text. We have secret scanning built into every GitHub repository, whether it's private or public. And with that, it finds secrets, it notifies the administrator, and we remediate that issue. We talked a little bit at CodeQL where your code is treated as data, and it scans the code as it's created to find those vulnerabilities. Then we have Dependabot. And Dependabot's great because it shows us what dependency packages are in our repository that create issues in our code. Whether you have NPM packages or high-risk packages, those are risks in your supply chain because the reality is a lot of us use open source software. So we want to look at how we can integrate policy and scan our container. So I told you I have Microsoft Defender hooked into what we're doing. I'll show you the scan results in a minute, and I will go into Microsoft Defender, and we'll look at how that platform looks. And we can also manage our secrets. So I'm using GitHub secrets. You can also use Azure Key Vault. It doesn't really matter. It's whatever kind of floats your boat, really, for your organization, what fits best. So we can see that our environment here has deployed to test. I've put in a manual gate. Oh, no, we can't see it, sorry. All right, so we can see here that the deploy to staging has a manual gate. So it's deployed to test, it's all green. Let's look what the container scan did. No vulnerabilities were found in our container image. Awesome. That means we can continue. Now, if this container scan fails, my entire pipeline fails because it isn't secure. We don't let it go past go. In Microsoft engineering, different product groups function a little differently, but the Azure product group team runs over 51,000 unit tests for every single PR commit. 51,000, and they run it in about 20 minutes. So if anything fails, we stop. So in this pipeline, if that container scan fails, my entire pipeline fails because it's not secure. We don't go forward with it. So there are no fatal warnings, but there is a single warning and 2 informational. We'll check those out in a minute. So I can go ahead and look at my code. I can see that my test environment's running. I want to go ahead and click on this link that I populated and see what our code looks like. Now, this is all dependent on the internet working. I feel like we need elevator hold music while this is coming up, but it should work. There we go. Azure Lowlands 2022. I'm happy with this. Is everyone happy with it? All right. So I've put in a manual gate because I want that human interaction. I want to review my deployment. I need that physical check. Yes, staging's okay. Our container scan, we're all green in our pipeline. So I'm going to type that we're okay to proceed. I can reject this, but I'm going to approve and deploy. So we're going to go to our next environment now, and it's going to go to our staging environment. So while that's running, I want to go through a couple of the security features that I spoke about. Actually, I'm going to use a different repository for that, because while this repository is great, I have yet to actually break it. So we're going to go to this repository, which is, I call my broken repository. So I've configured CodeQL, et cetera, and code scanning. The code scanning has found some clear text logging in this repository with my code. It's highlighted it. It's obviously high importance. I want to prioritize that. I can open that up, and I can make the changes. Now, I can dismiss the alert, but I probably don't want to. So we have to think about what we did. We pushed some code today, and in this repository, someone has pushed a plain text password. How do we prevent that? GitHub has just launched GitHub Push Protection as part of the advanced security package. And with that, it will pick up things as you're pushing your PR. So this is already sitting in our repository. That's still a risk, right? Because it happened to Uber. They got breached. Why not us? So looking at GitHub Push Protection, we have the ability to catch these things as our developers are pushing their code. So if I'm writing some infrastructure as code, I put in a connection string from whatever front end or server I'm running into my database. It will catch that, it will stop my PR, and it will fail. It will not allow it to push because I wrote bad code. So I look at Dependabot alerts, right? So we're using other open source packages. Open source is amazing. It enables us to be better people. It allows us to share our code and build that community sense. But if something is out of date, we need to know about it because it makes our software vulnerable. So with Dependabot, I can see that there are some critical things in here, some moderately critical things, and some highly important things. And it will tell me when I open it up how to remediate it. I need to patch my dependencies within my code. Because as a developer, how do you keep track of everything that's going on within your code and all your everything, your entire environment, especially if you have a pretty large environment to monitor? So let's see where our actions are going. Let's see how everything's doing. All right, so we've deployed again to our staging environment. Let's pull it up and see what happens. We're going to come back to that one. It will load, I promise. Oh, there we go. All right, so our staging environment's ready to go. We can now send this to production. So we've developed in a secure environment. We've pushed our code up to our repository. We're running security tools on it to make sure we don't put in passwords. We can check all our dependencies. Our container scans showed that we had no errors in our container scans. So when I go to my Azure Container Registry, this is the Azure Container Registry for this application. I can go into the repository here, and I have used the SHA code for each and every one of my deployments. Again, I could use a pull request number, and I can pull up the tag here, and I can trace it end to end. And I can look at how it all created and went through. I can also look at Microsoft Defender, and I do have images that aren't good in my Azure Container Registry. It's in that same registry, but it's not the image I just put up. So it will tell me where I have vulnerable images. It will tell me what the image is. It has the tag, and it will tell me everything else about it so I can remediate it. Because if it fails in my GitHub action, I don't want to push that image. So we've tied this all in with Microsoft Defender. So remember, our customers are multi-cloud. That's the reality. So I've pushed this to Azure. I can absolutely push this to AWS or GCP or on-prem to my server environment. I have full visibility of all those environments from Microsoft Defender. This is the end-to-end I need. Because what we hit is if we're deploying to one cloud, and that cloud has one tool for that cloud, how many tools are we managing, right? We don't want to have to manage all these tools and teach all our teams to learn all these things that are going on. I can also look at my regulatory compliance. I very often work with customers, as in often every day, that have some kind of regulatory compliance, whether it's HIPAA, SOC, ISO, et cetera. We need to know what our dashboards look like. So Microsoft Defender helps us give us that wraparound into our product. So we can see in our job summary here, we've built and pushed our Docker image, we've deployed and created our container to the cloud, we deployed to test, we deployed to staging, and we're good to go. We can go to production now. And we can look at each job, and each step is going to be the exact same. So we've scanned our image for vulnerability. We have logging enabled. I can see everything in App Insights. When I go to my staging environment, I can see what everything's done. My tests, staging, and production are going to have the exact same steps. So I want to show you a little bit of a reference architecture because everyone loves a pretty picture, right? How do we deliver end-to-end, right? We do this from day one. That is DevOps. Whether it's our inner loop, using our IDEs, dev containers, where we're building, testing, and writing our code. Are we using GitHub? Or whether using Azure DevOps, doesn't matter. All these tools have that capability. Then we go to our build and release. Are we running tests? Are we running scans on everything? And when we deploy it, how are we deploying it? Everything is code. Whether we're using GitHub Actions, infrastructure as code, whether that's ARM, Bicep, Terraform, and Azure policy. We want our policy as code as well and hook that into our pipelines. And we need to have that feedback loop, which is absolutely critical. Because remember, DevOps is a process. So we need to iterate to be better every single time. We need to start with something that hurts and keep on doing it to make it better. So I have a ton of resources here for you. I'm happy to share afterwards as well. How to get started with GitHub and Azure integration, GitHub Actions for Azure, Defender for containers, and then access to the repo. If you want to go ahead and break my demo live, feel free. But I want to also remind you, want to donate to Girls Who Code, because this is a really important initiative. I'm going to go ahead and open it up for some questions. Wake up a little, stand up, shout. Yes. Yes. Yes, so I will go ahead and put this back up on the screen.
My second question is, you had steps that you repeat for all your environments, like test acceptance, etc. But they do the same thing, and they check the same thing. What makes it necessary to repeat those steps?
So the question was, in each of my environments, I'm running the exact same steps, and I'm happy to bring that up on the screen if you want. The reason why is every environment must pass the gate and must be identical. So if we think of how we used to test software a lot of times, we'd either deploy it straight to production, or we test it in an environment that was not identical to production. But we need to make sure our code passes every single time, because there could be an anomaly. I don't have a screenshot of it, but I've absolutely worked on projects where test, staging, and production, or canary environments, were identical, absolutely identical. And even though they're identical, it failed going to production, or it failed going to staging, because there was some anomaly in the code. And often, sometimes something will work once and not work again. Great example. How many of you write Terraform code? Yeah. Terraform has some specifics when it deploys. It doesn't deploy the same way every time. It runs through Terraform Graph, and it calls the Azure API. It doesn't deploy in the exact same order. If you've ever worked with Terraform Graph, you could have a very exciting time reading this, but that's a good way to troubleshoot. So Terraform can deploy an infrastructure at work and then not work the next time. So that's why we run the exact same tests on every single environment. Now in the Terraform case, we have to put in depends on, especially to things like networking or other dependencies. So it did work in our test environment. We do not want to push that production without the same tests, without question. Any other questions? All right, I'm going to go ahead and close it off today. I will be hanging around out here-ish. Potentially drinking a beer shortly. So please feel free to come up to me, ask any questions, reach out, and thank you all for attending today.